Good morning, good evening, good afternoon, depending on where you are. Today is November 28th, and this is another of our SIG Apps bi-weekly calls. My name is Mate, and I'll be your host today. I have one announcement. The 126 release is planned for the next Tuesday, if I'm looking correctly. And based on the emails that I saw earlier today, there has been no problems. So it looks like we are on the schedule to be released on time for December 6th. So that will be the only thing, and we can move on to the discussions. Drew and Peter, I haven't seen Peter on the call. Maybe he joined in the meantime. Take it away from here.
Sure. Hi, I'm Dhruv. I'm from Shopify, and I've been working with Peter as well from Google to basically propose these improvements to stateful sets. Apologize a bit for my voice. I've kind of lost it. I'm recovering it, so if yeah, there might be a few hiccups. So I'm going to be talking about adding zonal rollouts for stateful sets and general zone awareness for PDBs as well. Um, the use case we came up with for this was for initially for Kafka deployments at Shopify. So I'll use that as a case study. So that YAML file you see on the side is roughly how we deploy Kafka at Shopify. For those who don't know, Kafka is a distributed event store deployed as a stateful set for us. Kafka is rack or topology aware. So if you have replicas of data, 3 of them, for example, and 3 zones, then Kafka will replicate this across the zones. One key thing we rely on when we deploy is the readiness probe, which essentially is a command which checks if a pod is caught up enough rather with replication of data. I think different databases and things have different kind of commands which are kind of similar. And one key thing when you deploy this as a stateful set is if 3 or more pods are down at random at any point, we run the risk of data loss and unavailable partitions because it could be from 3 different zones, and then we could lose all 3 replicas for something. So the problem we had is that deploying these stateful sets can take a very long time with a default rolling strategy.
So is your data loss because you don't? What's the durability that you configure your Kafka with? Is that the reason you would lose data?
Oh yeah, no, I'm just saying, that if you, we have a replication factor of 3 for basically every partition, which is the lowest denominator where how Kafka replicates things. So basically, if there's ever a disruption and more than 3 pods are done at the same time, you technically may be at risk of losing the data. Does that make sense?
Well, okay, so it makes sense if you're saying that you basically have a very long time between the data being committed to Kafka and being synchronized with storage media. So if all 3 go down, you lose partitions and they're unrecoverable because Kafka is configurable to allow you to write much faster than the disk moves.
I see.
That your use case? Sure. Like, is the durability configuration for the topic such that you would lose data if it goes down?
Right. I think I've worded it a little incorrectly then. I think it's more about unavailability than necessarily data loss, because it's data loss in the term of if you're trying to reach and write to a certain partition for which there are no replicas available, then you're losing data in that regard. But yeah, other than that, Kafka is pretty resilient with what you described, where it does frequently flush the disk and write whatever is available. So it's more data loss as in people who are relying on writing messages to Kafka would be losing data because there's nothing to write to. It's like if your database is down when people are trying to write to it, then you're going to lose messages there. Does that clarify?
Yeah, thanks.
Yeah, sorry, I should have been clearer. So the issue we were facing is for some of our largest Kafka clusters, which can be in the order of 200 to 300 brokers or pods. It can take some in the order of 20 hours to like more than that even to deploy, because we have to rely on the default strategy to roll out in 1 pod at a time. These pods cannot be updated at random, as I mentioned. If you set that to something like max enable 25%, you could accidentally take down all 3 replicas for something. That's the 3-pod restriction I was talking about. And so we want these deployments to be faster, not just from the perspective of ops that, I would like my rollouts to happen within working hours, but also, at least for Kafka's use case, we prefer shorter disruptions because of clients who connect and consume from Kafka. The longer a rollout might take, the more time they might perform rebalances, where basically they do no work. So the key insight we realize is that we can disrupt all pods in a given zone and still have the other 2 replicas for data being available. And so we can basically update our stateful stats by updating all pods in a zone at once. And it doesn't have to be all pods. I think the AWS use case was they were going exponentially. They would start 1 pod at a time, then 2, then 4, and so on to whatever max and available is. But the point is, these kind of apps can tolerate a lot of disruption in a given zone. And we can leverage that for faster deploys, be it for your app or even node upgrades and things like that. So one thing a lot of people, when we talk about this thing, is like pod disruption budgets could help with this. They don't, because they're not limited. Deploys are not limited by PDBs when you're doing rolling upgrades. But regardless of that, we also want PDBs to be aware of zones as well. So the way we solve this essentially is by writing our own controller or operator. We call it the zonal deploy controller. It uses the popular controller runtime library. And basically, we now deploy our stateful set with the on delete strategy. And on relevant updates, which for us is mostly a change in revision or a change in certain annotations, the controller takes over the deploy. We update all pods in the same zone at the same time. You could also configure it to be like 20 pods at a time or something if you want. And as I mentioned before, we heavily rely on the readiness probe for the stateful set to tell us when the pod is up and running. And if pods are unhealthy after restarting a zone, then the controller stalls and doesn't make any progress. We also have a pause field, which I think mirrors what deploys have. For some reason, we can pause deploys in Kubernetes, but not stateful sets. So ideally, we can add that too. So with this controller, we saw that our deploys basically took around 6 minutes per zone, and we went down. And since we have 3 zones, we're basically down to 20 minutes from 20 hours, which is a huge win, operationally speaking. Our client disruptions are minimized for the shorter duration of time. As I mentioned, there's a certain thing called consumer groups. And if any kind of outage happens to what they're looking for, they basically stop the world, rebalance, and they're not consuming anything in that time. So the shorter the disruption window, the better it is for them. And the way we designed this controller, felt like it was a native feature, and it just worked with our deploy pipelines as well. And we designed it to be generic. And for now, we're only using it to deploy Kafka, but there's another team which uses Elasticsearch, which can basically use the exact same solution. So I guess what we're really proposing is to upstream this kind of zonal awareness for stateful sets. Just like Kafka, there's a lot of other apps which can tolerate disruptions in many pods if limited to the same zone. And I think Kubernetes would benefit by offering these kind of features. And I think it should be native to Kubernetes. So the 2 things we think that will have high impacts is the ability to roll out pods by zone for a stateful set, and to allow PDBs to have a budget of disruption per zone as well. So basically, rollouts and PDBs should be zonal topology aware. And again, the goal for both these features is to essentially speed up deployment times without having an impact on any kind of availability. So we kind of prototype what this might look like. There's a picture on the right there of what it might be, where the main thing is maybe you can come up with a new update strategy type, like zonal update, where you can define a key. The main semantics, I think, though, that any kind of like zonal rollout should have is that the zones should be updated always in the same order. Whether that's specifiable in the YAML file or something like that, I don't know. We can have a discussion on that. And the reason that's important is, for example, if you deploy a bad change and you need to roll back or maybe have a fix-it forward change or something like that, then it's useful to update the same pods which were just which are down now, rather than starting from some other place. And all pods in a zone should be updated before moving on to the next one. Apps can use the readiness probe really to control how fast the deploy is happening and to see if they're caught up. For us, each pod reports their own health, but it could honestly, you could be reporting the general health of the entire cluster as well, or whatever. I think that's where people can customize how this rollout strategy would interact with their app a bit. And if pods are unhealthy after resetting a zone, then the controller should just stall. As I mentioned before, it would also be nice if we can pause these rollouts, like deployment support. These are some other examples we came up with. The image on the top left is the one I just showed, which is you can have a new update strategy called zonal update. The one below that, bottom left, is you could keep rolling update, but perhaps update the partition type to not only support something like an ordinal, but maybe a label selector. And then you can have the partition key be something like the host name. And that's actually incorrect. That needs to be the topology key there. Or you could have something we have on the right, which is, again, you have a new update strategy like zonal update. You can define what is the max unavailability per zone, like 20% or 10 pods. And you can define what order it might be, or what key it might be, for example, alphabetical here, or any mix and match of these. This is the part where we don't know what it really should look like here. And people with more experience, please, pitch in. But we just wanted to give a couple of different things or ideas we had for this. Yeah, and it's not just us. I think there's other people on the call. There's Mariana from AWS who implemented essentially the same controller we did at Shopify to speed up deploys for, I think, Prometheus. And then we have Peter from Google, I think, who is working on a feature to migrate stateful sets where having zonal pod disruption budgets would also be very useful for speeding up those migrations. And we actually do that. When we do cross cluster migrations for Kafka, we are trying to take zone into account as well. And I don't think I mentioned it, but it's not just Kafka. There's a lot of stateful apps out there which would benefit from this.
Yeah.
So, yeah.
I think two things. One, have you open sourced it?
No, but the AWS one is.
Okay. So that would be good. It would be good to get something in the open source community that people can iterate on and give feedback up before proposing to take an entry. So they give us an opportunity to kind of iterate on that API and lock it down before you try to V1 it or build it into an alpha feature even. Because with the way the release train works now, you can back an alpha out, but if you want to move it forward, there's not the whole thing like we did with V1 where we let it soak for 2 years before we V1'd anything is no longer a thing, purposefully so. So getting some in the wild feedback on an API that's being used across Shopify, AWS, and Google would be a strong motivator to upstream something. Then my other thing would be, so very many users use Kubernetes on top of a cloud provider, and the failure domains there are most easily specified in terms of regions and zones, right? But many users also use it on top of do-it-yourself data centers, right? And their failure domains are not going to be necessarily described in the same way, right? So in terms of topology spread constraints, which we already have introduced in the pod spec for being able to spread out, instead of calling it zonal, we should probably, if we want to do this, we need to be able to handle arbitrary failure domains in terms of the topology spread, right? So, and I don't think that there's anything that would block doing that, but I would look at the API and go back and say, okay, well, how do we make sure that we can generalize this to the use case of somebody who, instead of going across zones, is going across power domains, network domains, racks, so forth and so on. But yeah, other than that, it seems cool. I mean, I have no opposition to it in general practice, but those would be the two things, getting some more real world hit on a common API that multiple people are using, as opposed to we have one from AWS and one from Shopify, and we're going to try to select best of breed, would help push us in the right direction so we know we're doing the right thing. And being able to handle arbitrary topologies would be more inclusive of users who are not running it on top of the cloud, which, over time that may not be as many people. We expect more and more workloads to move out of do-it-yourself data centers, but today there's still a lot that run on it.
So just one thing with that, I think a common pattern we've seen is it's not just us writing these operators, but for a lot of stateful sets, people would just deploy them in general using operators, and this is kind of baked in there. They have a lot of logic. How do you recommend we gather these use cases, I suppose? Because we have one from AWS, we can come up with two from Shopify. Do we like further reach out to the communities, or like how do we go about that?
What would be awesome is if there are multiple people that are all working. So, okay, in the same way that you said, this is great. And the reason this is great is because we believe that this controller that we have will work for multiple workloads, all doing the same thing, right? I would assume that the same thing is true about what AWS is building. If we could convert, we could form a working group if that would help. I'm open to any suggestion about how we can help gather a community around it and converge it to one open source thing. I would really love to do that prior to start to baking it into the API, like outright, if that's possible.
In parallel to the zonal rollout, the pausing of the workload controllers has been mentioned in the past couple of times during the batch work group meetings. And just like it is currently implemented for deployments and cron jobs and jobs currently, there has been requests also to have the identical functionality for the remaining controllers.
I can give some context as to why that is. It wasn't thoughtless. When we were V1ing the APIs, the feedback that we were given by the architecture SIG was that the pause primitive in deployment wasn't declarative and was not compatible with GitOps style workflows and automated orchestration at a higher level, which is why we didn't because we looked at including it in the rest of the workload primitives resources prior to V1ing. But there was pushback more broadly. And that's not to say that we can't revisit it. We can always revisit it, but it wasn't done capriciously or because we thought that it was like let's V1 it without this feature and add it later. It was let's not add it. But maybe it's time to revisit that position.
I have a quick question, if it's a good moment. It wasn't apparent. What are the changes to PDBs required by this proposal? It seems like none. Could you please clarify that? Because you mentioned PDB a couple times.
I think for PDBs, the workaround, or I guess the solution the problem we want to solve is that for many apps, there is a discrepancy between the unavailability cross-zone and intrazone. So you may be able to have more pod disruption in a single zone, but if you do have a significant disruption event in one zone, you don't want your budget to be affected across the other zones. I think the challenge that Drew was pointing out was for the replication factor of 2 in Kafka, you can't have more than 2, assuming you have partitions sharded fairly uniformly. You may have a case where you can't take down more than 2 pods, even if you have a Kafka cluster that's very large, and it's really dependent on the scale of your zone replication.
In our case at AWS, EKS has this managed node groups, and during node groups upgrades, when you need to, for example, update your OS with new security patches, it uses PDBs to in case the pods don't become half of a node group update, it aborts the node group upgrade in that case. So in our case, why we created the zone where PDB was because we wanted to have a way to safely start to update multiple nodes at the same time and have this safeguard in case something goes badly, we can pause the rollout.
To clarify, when you're saying zone-aware PDB, is that the regular core PDB with additional labels, or is it separate object on top, separate from core PDB?
Yeah, what we did was like we created a new admission webhook. So with that's basically watched for the pod's status between the zones, and then using that information allows or not the request to go to the eviction API. So in our case, we kind of create a new object. I'm not sure on the PDB and to be honest, we copied a lot of the code at the PDB code. But we had to like create a new the status is you need to keep monitoring how many pods we have per AZ, how many disruptions we have per AZ. Kind of the status that we use was really different from the PDB. What we have on the PDB one is basically per zone. That like entering in our implementation details, but I believe maybe we could discuss if we could extend the PDB's current.
I would say this, I can at least understand, I can understand the use case for making staple sets or other workload orchestrators aware of topology constraints during pod termination, right? But if you're going to do it, like, I don't know what that looks like for PDB. Like we just offered a couple of APIs that are like very targeted towards zone, but I can understand like how you could extend that to work with an arbitrary topology constraint.
Mm-hmm.
PDBs are designed to work on label selectors, right? Like yeah, I mean, like, is that even compatible? Like, would label selection be compatible with topology constraints? Because you're saying specifically like these pods are grouped together and I only want X number of them to be disrupted. How would you, like, I guess maybe you could say like, I want these pods to be grouped together and I want X of them to be, only X of them to be disrupted at any given time, and prefer, maybe like a preferred zonal constraint. And that is kind of the way like the zonal constraints are specified for scheduling. You have preferred and required, right? Like, I could see that, but yeah, I just like, I'm not opposed to the idea, but I'm not seeing, I haven't seen so far today anybody offer like, this is what we think an API would look like and to handle those cases, which, I mean, sounds like a good project to work on if we can come up with how that works.
Yeah, main concern about using the admission API to reject eviction calls is that essentially eviction comes in from two sources, scheduling preemption and drain, right? So essentially, if you reject eviction and actually scheduler who drives the preemption, that may lead to unexpected results because scheduler actually want to preempt that pod because it needs to find room for high priority pod. Yes, that's a stateful pod. Yes, it's protected by your own custom PDB logic, but ultimately scheduler needs to find room for the high priority pod. So I think that could be a little bit concerning if you try to use admission hook to reject eviction APIs.
I wouldn't do that in the general case, right? And then, but that is the kind of thing. Like, if we're going to solve something that allows PDB to be a bit more expressive in terms of like preference toward pod termination, it does affect scheduling, it affects eviction, it affects draining. So, and I'm not saying that's it's possible to do that potentially, but we have to be thoughtful.
Agreed.
Just wanted to throw a thought out there. So I know PDBs today, if you have overlapping PDBs, eviction is not allowed. Like a potential option is allowing overlapping PDBs and kind of relaxing that constraint. I don't know how complicated that is though, but.
That is fantastic segue. I have the follow-up item. I have the requested proposal, and I think I'm going to link it at the end. Request and review for supporting multiple PDBs or overlapping PDBs. It was assigned to SIG Apps a couple of weeks ago. I proposed it roughly a month ago, so I would love to get feedback on that proposal.
Okay, that we can do. I think one of the challenges in particular with our customers that use PDBs as kind of a communication between clients who run on their clusters and their own like node update protocols for managed nodes is that like if you allow them to be too aggressive, then it's hard for people who are providing Kubernetes as a service to respect those PDBs when they're doing managed node upgrades, right? That it can basically take forever. So, but again, I mean, like, yeah, like if the community really wants it, I'm not super opposed to it personally.
So I just want to go back to the topic of the stateful set updates. And one thought that occurred to me was today with stateful set updates, your updates are declarative. So you say, okay, I want to be able to update to this partition, X number of replicas updated out of N. If we're doing this along, say, topology-aware boundaries, the state that you update to is dependent on the current state of a stateful set and the current state of those pods, which zone they're scheduled to. I think for, say, a stateful set that has PVCs that are assigned to specific topologies, that doesn't matter as much because those topologies are fairly static. But we can get into some weird scenarios where maybe you're rescheduling and then you're rescheduling to a different topology group. So you're not necessarily deterministically doing an update. But I kind of want to get, like, as a general principle, does SIG Apps have any thoughts about like risks there in terms of using pod state for these updates?
I guess here's my question. So one thing for, okay, so for, it depends on what your PVC is baked on in terms of whether it's actually zonally locked or not, right? So if you're using like Elastic File Store in AWS, then you can move it all over the place. If you're using EBS, and then for Google, it depends on which version of PD you're using, right? Like they do have multi-zonal PD. So the storage topology is a much longer conversation, which has been going on between SIG Apps, scheduling, and storage for a while. I don't think we made any progress on trying to actually do better with that, to be honest. But that's a conversation we should probably have as well. I'm not sure that this is not declarative. Well, I guess I'd ask, like, why is it not declarative? It's clearly non-deterministic, right? Which is definitely a change. But deployments, and when they're updating replica sets, that behavior is non-deterministic at intermediate states, right? Like eventually you converge toward, you have X number of replicas, but at any given point, regardless of what you specified as max surge and min unavailable, like if you specify a max surge of 5, you may end up at some point surging to 6 just due to network partitions, right? If you specify a min unavailable of 2 or 3, you may end up with 4 again, just because of network partitions. So like for most of the controllers, the behavior in turn, it's never been completely deterministic, like a state machine, you're guaranteed to go from X, Y to Z. It just converges toward the user's declared state. So like, yeah, to me, it seems declarative, but I'm definitely open to hearing why it's not.
Yeah, I guess the non-declarative nature I'm thinking of is like the zonal spread may adjust, and that may have effects on the application. So like maybe from the like stateful set perspective, we're still declaring what the eventual outcome is going to be. But like Drew pointed out, there are maybe some rebalancing risks that you have if update takes too long and that sort of thing. So there's these side effects that may result if we're not necessarily rescheduling to the same zone that a pod was updated from.
Like the stateful set is kind of different in that, like, it's the dog wagging the tail, right? Like, or the tail wagging the dog, right? You schedule the storage and then the storage draws the pod to it. I don't necessarily think that would change if you made, because really what you're looking at, the proposal is basically like, what we want to do is we want to control termination so that we can burst it more rapidly across a particular failure domain, right? And because the storage in the case of where you're, in the case where you're on a cloud and you have zonal storage, you're still always going to get rescheduled to the same zone. Like that's just the way the scheduler is going to look at it. They're not going to put you on a node where you can't get the storage that you want. So yeah, I mean, like, I don't see it, like, you're saying, like, if someone adds a zone while you're doing the disruption, or like what's the use case you're thinking where it would be really super risky and edgy?
Yeah, I think either if you have like a capacity constraint during an update, like maybe you have a very aggressive autoscaler, scales down once resources are not being consumed.
That happens
Those
today, though. Like if you use cluster autoscaler on AWS with EBS, just as a for instance, and you scale down to 0 and you have stateful sets that are provisioned and looking to try to mount volumes in the zone where it's already been scaled down to 0, you can get unschedulable pods that just kind of hang and break. So that is already a thing.
Okay. Yeah, that makes sense.
Okay, hearing none, let's jump to the other two topics.
Sorry, I have a question.
Yeah, go ahead.
Okay, just wanted to clarify the expectations about the next steps for the stateful set update strategy proposal specifically. I heard that we want to solidify the API in public, but I'm wondering what the bar is, like what we're looking for specifically before we would accept a KEP as the forum for discussion on what that API looks like. Because what I'm hearing is that there are already a bunch of different companies who have either open source or closed source implementations of this, that they have some API that they're using, and whether or not they're able to share the code and have like competing essentially out of tree solutions to this, they can probably share the API that's been successful for them. So I'm wondering if and when a KEP would be the appropriate forum for that discussion.
It's really up to the contributors, right? Like if you guys want to move forward with a KEP right now, we'll review it. And if we think we can be confident and you're willing to contribute the code to make it run, we will shepherd it through and commit it. I'm just suggesting that you might want, if you have working code right now, right? One thing that has in the past helped motivate contributions to move rapidly in tree with a large degree of success is to do it as an open source thing and start a working group and then just merge it in after. If you don't want to do that, I mean, like if you want to open a KEP, that's fine too.
Okay, thank you for clarifying.
They're your contributions. I just want to help you make them.
Great, thanks. Does that make sense, Drew?
Yeah, it does. I think, Mariana, we already have the thing open source and you're also willing to work on it. So maybe we can coordinate after as well.
Yeah, sure. Like we can discuss, for example, what we have that doesn't work for you at Shopify and start to discuss different type of problems.
Yeah, we were already talking about that. So yeah.
Cool.
One thing I would just put out there. So for a while now, SIG architecture has been very much in the position that we should do as much as possible using custom resources and out of tree, and then do the things that are really necessary to do in core, right? So that is kind of one motivator. Taking that approach might help build more community around it and help you get it through faster. That being said, like if for some reason you feel like it would be better just to take the approach of doing it in a KEP and building it in tree, you can feel free again to open up a KEP.
My only question with that is I've not been part of the process where with open source contributions, like I'm not used to the part, like we can, for example, I'm sure it's very easy for me to add what I need to Mariana's open source project. And then it's a team of 2 companies which know what it, who have this one open source solution. And maybe we can use it for the other Elasticsearch use case for us, right? But then how do we do that reach out to other people? How do we say, hey, listen, this exists. Maybe you want to use this, right? Because we're not advertisers for these features. I don't know if there's a forum to talk about this or where people engage about this. So my concern is it'll just stall at that point where like, it's just us. We figured this out, and then where do we go from there?
We can help create a forum for you. So we could do a SIG Act working group specifically on like topology aware updates. I would love to see that evolve to also respect daemon sets. We could involve SIG scheduling because I'm sure they would be interested as well, and see if we can get some contributors from there that would also kind of lend in. So that would be one path. If you look at, for instance, snapshots, right? Like that's a feature that has broad utilization across the community that it's not in tree at all, right? It evolved completely alongside of it, right? So there are ways that we can make this happen if there is enough interest, and it doesn't have to be a large group of contributors to do it. You know, if you feel like I am hearing that people are saying maybe we have enough data. Like if you feel like there is enough data from various users, you can also go and open up a cap. My one pushback would be, again, from what I've seen presented today, is that the data you have seems very cloud provider focused, and even like the type of topology that you're talking about respecting is native to cloud providers, right? Which isn't representative of the entire community of users. So just looking at the API you have, I'm like, that may not be ready. And the first feedback you're probably going to get from the broader community is that, well, this is very different from the topology constraints that we use for zonal spreading, which are aware of arbitrary or potentially support arbitrary failure domains. And this is very focused on cloud provider zones. You know, so like, and there's, again, if you do that out of tree, there's nothing wrong with doing that at all, right? Like you can have cloud provider specific functionality or functionality that's specific to supporting Kubernetes running on public cloud. But if you want to build it in tree, then coming down to a common denominator that can be leveraged for people who are running on do-it-yourself data centers would probably be part of the mandate for like actually merging it, right? Like you can't say like, well, if you don't have a concept of a zone, you have to, inside of the failure domains that you're running your infrastructure on top of, come up with that concept in order to use this feature. Especially when the scheduling constraints that we use for anti-affinity and affinity don't work that way.
So just two things on that. Can we not reuse the same idea of just having letting people specify a generic label like we do for affinity, anti-infinity? Can we not just adopt that and
That would be
call it good enough?
That would be how I would approach it, right? But
okay,
like if you were going to open source what you had today and make it public available, that isn't what you built or what you've been using, right? And it's not what AWS has built or has been using, from what I can tell. So if we're going to like, if we're going to build something and then build it in tree, my opinion, right, which is not, this is just advisory, would be I would do it out of tree first because you can iterate very rapidly on it, get some use on it, bring that back in-house, use it at AWS, use it at Shopify, demonstrate that you've got the right thing. And then that's a strong motivator for like, well, and Google too. I mean, you have 2 out of like 3 of the largest public clouds already using it on top of, you know, some major tech companies like Shopify already using it. Doesn't make sense to not take it in tree at that point, right? That's kind of my 2 cents. Now, the other thing would be like, if we find it's too difficult to do, like, because if you want to use stateful set as a primitive, if you're not trying to fork stateful set and you want it to be a rolling update mechanism that's embedded into the controller itself, it may prove that like, okay, the only way to do this is as an alpha feature inside of stateful set, which, you know, we do a cap and do it that way too. That's also not a bad path, but it seems like you were able to do this out of tree already, at least in several cases, having one method that, you know, is like, this is great, it works for all 3 of us, as opposed to 3 different things. And then saying, well, this is what we would like to take as an API and offer to the public in general to utilize would be a very strong case to me.
okay, thank you.
A different venue that you might want to reach out to is Michelle from SIG Storage reached out to us last time. There is a link to the data on Kubernetes community. They are specifically talking about running storage related applications on Kube. Maybe worth syncing with them. We're planning to reach out to them as a group and gather their additional feedback. Maybe they will be able to either confirm your current approaches or add additional use cases that you might not have thought about before, or basically give more info.
Yeah, let me stump for that a little bit more. We're working on related issues, not directly related, but related issues in the data protection working group of SIG Storage. So just stumping for that.
Awesome. Thank you.
Okay, final call. Does anyone else have any questions? Last minute comments? Okay, cool. The two other items I see from Raul and Ilya, both of them they've been brought up a couple of times before. I remember, Ken, that you were requested to look at the PVC recreation from last time. I'm not sure if you had any chance. It would be nice to for you to have a look, and probably a similar question for Ilya PR about the multiple PDBs on a pod.
Yeah, I can take a look. I wasn't aware of the multiple PDB. It's a PVC recreation or PVC deletion, PV deletion?
Recreation.
We'll take a look.
Thanks.
Okay, thanks a lot. Does anyone else have any other topics that they want to bring up with the group? Okay, hearing none. So thank you very much all today, and see you next time. Enjoy the rest of your day. Take care.
Thanks.